Hi, everyone. We are Kristen Kirk and Rushi Patel. For our project, we tackled an urgent healthcare challenge, diabetes. Our goal, use AI to identify high-risk individuals early before the symptoms become life-threatening.
Diabetes is a chronic metabolic disorder that disrupts how our bodies process blood sugar. Left unchecked, it can lead to heart disease, kidney failure, and nerve damage. Early diagnosis is critical, but in reality, it's often missed. That's where predictive modeling comes in. We use the Prima Indians Diabetes Database, diagnostic data from women aged 21 and over of Pima Indian heritage. It includes standard health metrics like glucose, blood pressure, BMI, body mass index, insulin, and more. It's compact but powerful enough to train a meaningful model. Of course, the data set wasn't perfect. We found physiologically impossible zero values, like a blood pressure of zero, which treated as missing. Plus, most patients didn't have diabetes, so we had to correct for severe in class imbalance.
To fix missing values, we tested multiple methods and chose mice, an iterative, multivariate imputer that gave us the most realistic structured replacements. When we when we powered up our data, scaling it, combining features like glucose at times BMI, and squaring key values, these transformations helped our models detect subtle, nonlinear relationships. To address the class imbalance, we use SMOTE. It generates synthetic diabetic patients examples during training, helping the model better detect the minority class and those at risk.
We ran and tuned 6 models: logistic regression, random forest, XGBoost, SVM, KNN, and a stack ensemble. Each was optimized for ROC AUC, a key measure for how well a model distinguishes risk. The stacking classifier stood out with the best overall ROC AUC of 0.842. Random Forest gave us the best recall, catching more diabetics. Logistic regression gave the cleanest precision, but stacking gave the most reliable balance. To maximize clinical impact, we dropped the decision threshold from zero point 0.5 to zero point 0.3. That raised recall to nearly 87%. In real life, that means catching more at risk patients, exactly what a predictive tool should do. Glucose was the top feature, unsurprising but reassuring. It means the model's logic matches medical science. BMI, age, insulin, and family history also contributed heavily.
Our model doesn't replace doctors, it supports them. It outputs a probability of diabetes. High score means the patient should get further testing, potentially catching cases that would otherwise go unnoticed. From here, we wanted to test light GBM and CAT boost, expand to a more diverse data set, and eventually build on real clinical interfaces. This is just the beginning. Thank you so much, and we believe this project sits right at the intersection of AI and real-world impact. We're excited for the possibilities, and we welcome your questions and feedbacks now. Thank you so much.